Betelgeuse, that huge red star in Orion, is pretty interesting to people who study space. If you put it where our sun is, it would be bigger than Jupiter's orbit. It's a massive star, and it's changing a lot, which could mean it's about to blow up. Some scientists, like Brian Cox, are keeping an eye on it because it's been sending out weird signals. This makes you wonder if we're about to see a massive explosion that will totally change how the night sky looks. Scientists are really curious about it. Stars, like people, are born, live, and die, often in surprising ways. Betelgeuse is way out on the edge of our galaxy, and people are interested in it because it's old and huge. Its red color and how bright it is change a lot, which has always caught the eye of people who like to watch the stars. The recent changes have everyone asking even more questions about what's going to happen to it. Betelgeuse is getting close to the end of its life, and you can tell because it's so big. It's possibly 1,000 times bigger than the Sun. If it replaced the Sun, its outer layers would stretch past Mars, swallowing Mercury, Venus, Earth, and Mars. This size shows where it is in its life cycle. It ran out of hydrogen to burn in its core, so now it's getting bigger and cooler, which means it's almost done. Betelgeuse is maybe 8 to 8.5 million years old. That might sound like a lot to us, but it's old for a star. It used to be a hot blue star, but over millions of years, it changed into the cooler red supergiant it is now. These changes happen because of a balance between burning fuel and gravity, which makes stars get bigger and smaller. Betelgeuse is red because its surface is cooler than hotter stars like the Sun. The Sun is about 5,500 Kelvin, but Betelgeuse is only about 3,500 Kelvin. Because it's cooler, it gives off light that looks red. This isn't just about looks, though. It tells us a lot about what's going on inside the star and how it's changing. Betelgeuse hasn't always been red and bright. People in old times, like the Romans and Chinese, said it was yellow. It wasn't until the 9th century that Arabic stargazers noticed it turning red. This color change is just the star getting older and cooler. Besides the color, Betelgeuse is also a star that changes its brightness. It can change quickly, in days, or slowly over years. How bright Betelgeuse changes in weird ways, unlike other stars that are more predictable. This suggests there might be things going on inside that we don't fully understand. Something weird happened in 2019 when Betelgeuse got way dimmer than usual. People called it the Great Dimming, and it surprised scientists because Betelgeuse is usually one of the brightest things in the sky. It got dimmer by 0.01 magnitudes each day and was at its dimmest in February 2020. This made everyone wonder what was happening to it. One hard thing about studying Betelgeuse is that it takes 725 years for its light to reach us. So, when we look at it, we're seeing it as it was in the past, not as it is now. This makes it hard to keep up with changes and figure out what's going on. Because of all this weirdness, astronomers like Andrea Dupree from Harvard have been watching Betelgeuse closely with the Hubble Space Telescope. These observations have helped them understand what's happening in the outer layer of the star. The Hubble data showed that Betelgeuse was spitting out stuff at 200,000 miles per hour, creating a dust cloud that made it look dimmer. This loss of material has made some scientists think that Betelgeuse might be about to blow up in a supernova. So, the big question is whether Betelgeuse is about to go supernova. A supernova is when a star dies in a huge explosion. If Betelgeuse did this, it would be super bright enough to see during the day. It would be brighter than the full moon, and it would give us a chance to study the last moments of a huge star's life. It's far enough away, about 725 light-years, that it wouldn't hurt us. There are theories about why Betelgeuse got dimmer. One is that it's starting to go supernova, another is that the dust cloud blocked its light, and some think it could be changes in the outer layer of the star, maybe a big dark spot. Whatever the reason, scientists are paying close attention to the dimming. Red supergiants like Betelgeuse help us understand how stars change over time. These stars are at the end of their lives, right before they explode. They're huge but don't live very long, which makes them great for studying how stars die. Plus, when they explode, they make heavy stuff that's needed to make planets and maybe even life. If Betelgeuse explodes, it would be a great chance to see a supernova up close. Supernovas are important because they spread heavy stuff around, which then gets used to make new stars and planets. So, if Betelgeuse goes supernova, it could really help us understand these space events and be a cool sight for people to see even though it's far away. Studying Betelgeuse's dimming and death will teach us a lot about how stars grow old. Red supergiants give us clues about the universe, and their explosions shape galaxies and star systems. As astronomers keep watching Betelgeuse change, we're likely to learn new things about stars. Learning about red supergiants and how they die tells us how big stars live and die. By understanding this, scientists can guess better about how other stars will live. The way Betelgeuse acts might also help us figure out why some stars change. Astronomers might use Betelgeuse as a comparison to study other stars that change. The stuff that Betelgeuse is losing gives us a peek at what it's like for red supergiants as it gets close to the end. Its outer layers will get even more unstable and lose even more stuff. Understanding this is important for guessing how other red supergiants will change. Supernovas are exciting and also make heavy stuff all over the universe. When a big star like Betelgeuse explodes, it makes elements like iron, carbon, and oxygen, which are used to make new planets, stars, and maybe life. If Betelgeuse explodes, it would add to this cycle and help create new star systems. The blast waves from a supernova can squish gas clouds nearby, which starts new stars forming. The radiation from the explosion can also change what those new stars and planets are made of. Understanding this is important for knowing what will happen to the universe. As Betelgeuse keeps changing, astronomers will keep studying it with tools like the Hubble Space Telescope. These observations will give us data to improve our ideas about how stars change, especially things like losing material, changing brightness, and other things that happen to big stars. Basically, studying Betelgeuse gives us a great chance to learn about the life and death of stars, especially big ones. Our sun is medium-sized and lives a long time, but understanding red supergiants like Betelgeuse will help us guess what will happen to other big stars. The knowledge we get from Betelgeuse can also help us understand space things like galaxies, star clusters, and planets. As we keep watching Betelgeuse and other red supergiants, we'll get a better idea of how the universe works, which can help us answer some big questions about space. Besides the excitement about a possible supernova, Betelgeuse gives us a rare look at the end of a star's life. Its huge size, weird behavior, and coming death give us information about how stars change and die. Studying Betelgeuse helps us understand not just this star, but also how other big stars live and affect the universe. As scientists watch Betelgeuse change, they see it as a place to study how stars die. Understanding how it turns into a supernova, if it does, will help us understand how other stars like it follow the same path. Supernovas are important parts of a star's life and important times in the universe. Betelgeuse's actions, especially how it suddenly got dimmer and changes its brightness, give astronomers a way to improve their ideas about how red supergiants act as they get close to death. We don't know exactly why it got dimmer recently, but Betelgeuse is a key to understanding how stars die and how space works. The fact that Betelgeuse is losing so much stuff is another interesting thing about its last years. Because it's losing stuff so fast, scientists can learn more about how long similar stars live and how they will eventually die. This loss of material shows that Betelgeuse is about to die, but also helps us understand how red supergiants affect what's around them. The stuff it spits out will eventually mix with other material in space, which changes how new stars, planets, and other things are made. Astronomers are always getting new information about Betelgeuse using telescopes on the ground and in space. Observations from things like the Hubble Space Telescope help them understand the star's actions and changes inside, which helps them track how stars like Betelgeuse interact with what's around them, especially at the end of their lives. These studies also give us new ideas about how the loss of material and changing brightness of these stars shape our galaxy. The loss of material from Betelgeuse is particularly interesting because red supergiants like it send huge amounts of material into space, which really changes the space around them. This process adds heavy elements to space, which are needed to make future stars and planets. When these elements are sent into space, they become the building blocks for new stars, planets, and maybe even life. As Betelgeuse keeps going through the last parts of its life, astronomers know that its supernova could start new stars. The explosion would send out a lot of energy, squishing gas clouds nearby and starting the creation of new things in space. This is one of the main ways the universe renews itself, making the materials for the next group of stars and planets. Even though a supernova is exciting, it probably won't hurt Earth. Betelgeuse is so far away, about 725 light-years, that any harmful radiation or blasts wouldn't reach us. But the data we get during this process will keep giving us valuable information on how stars change, die, and add to the life cycle of the universe. These results will help us understand how future star events might affect other star systems in our galaxy. Betelgeuse's coming death, whether through a supernova or something else, will be studied a lot, not just because of the information it gives us, but also because it represents bigger ideas about how stars change. How the star acts as it gets close to the end can teach scientists more about how stars of all sizes age and die, allowing them to improve their ideas about star life cycles and what happens when a star runs out of fuel. Really, Betelgeuse as a changing star raises interesting questions for astronomers and science fans. As it gets close to the end, the star's middle will start to collapse under a lot of pressure from gravity, which causes huge reactions. These reactions could lead to a neutron star or even a black hole, depending on how Betelgeuse ends its life. This process is one of the main things scientists are interested in when studying the last moments of a star's life. Another interesting part of Betelgeuse's actions is how it helps add important elements to space. The explosion of a red supergiant like Betelgeuse in a supernova has a big effect on how the stuff in the galaxy changes. The heavy elements made in these explosions, like iron, magnesium, and silicon, become the building blocks for new stars, planets, and even life over time. These materials spread through space, making the materials needed for future stars and planets. Studying Betelgeuse also gives us a rare chance to understand how big star leftovers move, giving us ideas about what happens to other stars that are similar to it. By watching Betelgeuse, scientists can test and improve their ideas about how stars change and how their final explosions change the future of the universe. Betelgeuse, the massive red star in Orion, has astronomers wondering if it's about to blow. If it replaced our sun, it would stretch past Jupiter. Scientists like Brian Cox are curious about weird signals from Betelgeuse. Are we about to see a huge explosion that changes the night sky? Stars are born, live, and die, and Betelgeuse, hanging out on the edge of our galaxy, is huge and old. Its color and brightness changes have scientists watching, especially since it's nearing the end of its life. It's about 1,000 times bigger than the sun. If it replaced the sun, it would swallow Mercury, Venus, Earth, and Mars. It's expanded, cooled, and is running out of hydrogen. At 8 to 8.5 million years old, it shifted from blue to red. The red color means it's cooler, 3,500 Kelvin versus the sun's 5,500. Its color and brightness haven't been constant. The Romans and Chinese saw it as yellow. Arabic astronomers later noticed it was red. It's also a variable star, meaning its brightness changes. In 2019, it dimmed a lot concerning scientists. The light takes 725 years to reach us, so we're seeing its past, not its present. Astronomers are watching Betelgeuse with telescopes. Hubble data showed it ejected material at 200,000 miles per hour, creating a dusty cloud that dimmed it. This mass loss makes them think it might go supernova. If it does, it will be super bright, even during the day, but since it's 725 light-years away, it wouldn't harm us. Why did it dim? Maybe it's going supernova, or maybe dust blocked its light. Could also be changes on its surface. Big stars like Betelgeuse help us understand how stars die and create heavy stuff for planets and life. A supernova would be a great chance to observe up close and would enrich space with elements for new stars and planets. Studying Betelgeuse helps us learn about the universe, galaxies, and stars. Its changes give us hints about what makes stars vary in brightness. Betelgeuse's potential supernova is a key area of interest for astronomers, as its dramatic changes could provide a unique opportunity to study stellar death in real time. Understanding how a star like Betelgeuse transitions from a massive red supergiant to a supernova explosion is important because it gives insight into the life cycle of not only massive stars but also how galaxies evolve. This process is fundamental for understanding the larger structure of the universe, particularly when it comes to star formation and the spread of heavy elements that create the building blocks for planets, asteroids, and even life. What makes Betelgeuse even more intriguing is that, although we are observing it as it was centuries ago, scientists can still gather meaningful data about its behavior. By tracking its brightness fluctuations, analyzing its emitted radiation, and observing the material being ejected, Researchers can make predictions about how long it will take before the star reaches the end of its life. The possibility of a supernova provides an exciting opportunity to study a star's final moments, as we can observe the explosion's aftermath and the cosmic effects it creates. Such observations could give astronomers a clearer understanding of how stellar remnants, like neutron stars or black holes, are formed. Additionally, Betelgeuse's location in the Orion constellation makes it a perfect candidate for skywatchers, even those without advanced equipment, to witness significant astronomical events. If it does explode, the light show could become a rare spectacle visible to the naked eye. This could potentially stir interest in science and space exploration among the public. Furthermore, by studying Betelgeuse, we not only learn about the mechanics of supernovae but also about how the universe recycles material. The heavy elements dispersed in the aftermath will eventually help in the formation of new stars and planets, continuing the cycle of stellar life. Moreover, the study of stars like Betelgeuse could lead to more accurate models of stellar evolution. These models help scientists predict how other stars of similar size and mass will behave throughout their life cycles. By observing and analyzing Betelgeuse's end, astronomers will refine their understanding of stellar dynamics, the effects of mass loss, and the role of supernovae in shaping the universe's chemical composition.